Well, folks, welcome back. Like I've already indicated in the previous video, that we'll be tackling an example on arithmetic sequence and a geometric sequence. So in this video, we'll be specifically looking at an arithmetic sequence, an example for an arithmetic sequence. Okay. So if, like usual, if you are new to my channel, please subscribe. Don't forget to hit the notification button, share these videos with your friends and everybody at home, and like the page, comment. Your comments are very important to me. Okay, now without any further ado, let's not waste time and hop directly into the questions. Okay, but before we start, I will also advise you to watch the previous video so that you understand what is actually going on here. If you didn't watch the previous one, I will actually leave the link below so that it can take you to the previous video. Now let's check the following question. It says the following is an arithmetic sequence. The following is an arithmetic progression. Remember, I told you if you don't want to say sequence, you can actually say progression. Okay, so now you are given 1 minus p, 2p minus 3, p plus 5. So this type of a sequence is an algebraic sequence. When you say algebra means a combination of letters and numbers, variables and numbers. So in this case, because we have a sequence that is generated by letters and numbers, or the terms comprises of letters and numbers, then it's an algebraic arithmetic progression. All right, now it means in order for this to be a numeric sequence, we need to determine the value of p. That is why the first question says calculate the value of p. Okay, then for 3 marks. Remember, every mark in mathematics count. Okay, a mark can either leave you in a level 7 or it can take you to a level it can leave you in a level 6 or it can take you to a level 7. All right, now the second question says you write down the value of. I also indicated that the most important aspects, or the most important variables that you can actually deal, the most important parameters that you can deal with in either an arithmetic sequence or a geometric sequence are the first term and the common difference. That is why there is a question that says determine the first term and the common difference. And then lastly, you are expected to explain why none of the numbers in this arithmetic sequence are perfect squares. All right, and then that is 7 marks. This is a final examination question. It is taken from the NCS Mathematics Paper 1, February-March 2009 by Department of Education. This is question 3. Okay, so this is not a classwork. This is not a homework. This is not an exercise. It's exactly what you expect when you write your examination. All right, so you should make sure you really get along. If you have some problems, then you can always go back. You can always go back. Okay, you can always go forward, backward, just like that. And then if you have some questions, you put them in the comment section. Then I will make sure I respond to that. Okay, now let's proceed. So the first thing that we check is this is arithmetic progression. So the fact that it is arithmetic, there are certain things that we should remember or that we should review. Now let's review certain things here. Okay, 1, we know that in an arithmetic sequence, the first term is given by t1, which is equals to a. In this case, is 1 minus p. Okay, another thing that we know is that as long as it is arithmetic sequence, it will have a common difference d. And then how do we determine d? We'll always take the difference between any two successive or consecutive terms. So in this case, it will be t2 minus t1, and it must be equals to a. Pardon me, this is just a typing error. It's not equal sign, it's minus. So it's t2 minus t1 is equals to t3 minus t2. And another thing that is important is the general term. This is the nth term because our variable is n in this case. This is the last term. Okay, so you expect questions, you expect the examiner to ask you questions like revolving around these characteristics. These are the properties. Okay, these are the features of an arithmetic progression. So with that being said, and having this at the back of our minds, then we can actually look at the first one. If we are supposed to calculate the value of p, then it means out of all this, we can use the first term here, we can use the general term here, because in the general term we have many unknowns. But instead we know that the fact that it is arithmetic sequence, then it means d is equals to t2 minus t1, which is equals to t3 minus t2. So let's look at it. This will be our solution. You say, okay, we are actually having a sequence, and then we know in this sequence that minus 1 minus p is t1, 2p minus 3 is t2, and then p plus 5 is t3. And then what do we know about t1, t2, t3? Automatically out of our review, we know that t2 minus t1 is equals to t3 minus t. So this is what is supposed to help us. But firstly, let's understand that the difference between any two successive terms must give us the difference. And automatically between t2 and t3 must also give us the difference. And this difference is supposed to be common. It's supposed to be constant. Okay, that is why we have a constant difference here. So d is equals to d. Okay, let's write down the equation. We know d is equals to t2 minus t1, which is equals to t3 minus t2. Then if you are here, folks, you are done. Because the next step will just be to substitute these terms, and then you play your maths, then you find the value of d. All right, let's substitute. So it means where you see 1 minus p, where you see t2, you'll substitute by 2p minus 3. I'm using different colors here so that you can comprehend the concept very well. You can understand the concept very well. Okay, so now where you see t2, you put 2p minus 3 minus. Be careful here. This is minus for the formula, minus in the equation. It is not minus for any of the terms. So you must say minus. Term 1 is not 1. It is not minus p. Term 1 is 1 minus p. So you must put it inside the bracket to show that this is one term. Do not make a mistake of not putting the bracket. This is the tricky part of such kind of a question. Okay, so you put it inside the brackets. So on the right hand side, you do the same. Where you see t3, you put p plus 5 minus into 2p minus 3. Okay, now let's remove the brackets. It is well known to you to say negative and positive will give you negative, and negative and negative will give you positive. Hence, we'll have 2p minus 3 minus 1 plus p, which is equals to p plus 5 minus, because minus multiplied by positive 2p, it will give you a negative 2p. Remember, this is minus 1. Okay, the coefficient here is 1. It's just that we didn't write it. So minus 1 multiplied by 2p, it will be minus 2p. So minus 1 multiplied by minus 3, it will be positive 3. Okay, now we can actually simplify it to say, okay, 2p plus p, then that will give you 3p, and then minus 3 minus 1 is equals to minus 4, which is equals to p minus 2p is minus p, and then 5 plus 3 is equals to 8. You see, some of the steps that I'm going to write here are not necessary for somebody that has actually that has mastered the concept. But in this case, I want to accommodate everybody. So I'll write each and every step so that you understand where the value of p comes from. Okay? And then make sure that I don't leave you behind. All right. Now, from here, we can go back to grade 8 work. This is just grouping of terms. Okay, like terms. Then 3p will go along with minus p, minus 4, so on and so on. So you can actually add the additive inverses both sides. Or in simple terms, you can just say when you take a number or a variable to the other side of the equation, it must change the sign. Okay, so minus p will be positive, and then minus 4 will also be positive. You will remain with 3p plus p is equals to 8. Instead of minus 4, it is now 4p. Okay, now you can add 3p plus 3p is 4p, and then 8 plus 4 is 12. But let's go back to the question. It says calculate the value of p. It doesn't say calculate the value of 4p. Okay, so now it means we need p. Here is a problem. Then what are we supposed to do here in order to get the value of p? Exactly, divide both sides by 4. Okay, divide both sides by 4. Then you get 4p divided by 4 is equals to 12 divided by 4. All right, then from there you can divide, people. Never say 4 and 4 cancel. We don't cancel in mathematics. 4 divides in 4. Okay, 4 divides in 4 to give you 1. The same thing apply. 4 divides in 12 to give you a 3. You don't cancel. Why should you cancel? If you cancel, then the whole process of determining P is futile. Okay? You divide these numbers. Now, because mathematics is a language, you must speak it properly. You must speak it properly. Right. So this will be a 1P, okay? And then this is equals to 3. Therefore, it means P is equals to 3. Okay? How hard is that? Very, very, very simple. Now, this is how it's going to be marked in the final examination. You'll get a mark for the characteristic or for this property of an arithmetic sequence relative to the common difference. You also get a mark for any part of simplification here, okay, for removing your brackets. And then you get a mark for the final solution for saying P is equals to 3. Okay? So let's move on to the next question. The next question says write down the value of the first term. Remember, from the properties, from the review, T1 is equals to A, and T1 is equals to 1 minus P, and we know the value of P. Okay? Now this is your 3 marks. Let's go on. Right, in 1.2.1, T1 is equals to A. We know that, but this is given to be 1 minus P. And by the way, what is the value of P? 3. Exactly, you are with me. 3. Then you will just have 1 minus 3, and then A will be equals to minus 2. Okay, this was very simple. As long as you know the value of P, then it means you can determine the numeric sequence. And the first numeric term will be 1 minus 3, which is minus P. Which is A minus 2. Then you get a mark for that. Okay, this is the 1 mark that you'll get for answering this one. Now let's go to the second one. 1.2.2. We need the common difference. The common difference is given by either T2 minus T1 or T3 minus T2. Okay, there's no need to write all of them. Okay, now D is equals to T2 minus T1, or you can still say T2 minus T3 minus T2. You are welcome. All right. Now let's substitute the value of T2. We don't know the value of T2, but we know P2. Okay, T2, it will be 2 multiplied by 3 minus 3. Everything that is inside the square bracket, this is the value of T2. Okay, minus, this is the minus for the formula. And then this will be minus. Don't make a mistake. Put it inside the brackets here, and then you have minus 2. And surely 2 multiplied by 3 is 6. 6 minus 3 is 3. Okay, negative and negative is positive. 3 plus 2 is what you'll actually get, and that will give you 5. Therefore, it means the difference, okay, the difference between any 2 consecutive terms in this arithmetic sequence will be 5. The common constant, it will be 5. Then you get your 1 mark there, which is very, very important. Okay? Now let's look at the last one. With the last one, we are going to explain, but we must explain mathematically, and then with reasons. We must reason things out. Okay? Explain why none of the numbers in this arithmetic sequence are perfect. So it means no term in this arithmetic sequence will be a perfect square. So we want to explain why none of the numbers in the sequence are perfect squares. But firstly, before we do that, we must understand what a perfect square is. Okay? So perfect square, you know very well that perfect squares has square roots. Okay? So now, how do you get perfect square? Perfect squares are actually squares of natural numbers. If you say 1 squared, it's 1. You say 2 squared is 4. You say 3 squared is 9. Those numbers, all of them, 1, 4, 9, 16, 25, 36, 49, 81, 100, so on and so on. Those are perfect squares. Okay? They are perfect squares. Now, let's look at it. If we are saying none of them is going to be a perfect square, let's check. In this sequence, if you check, we can actually write the numeric sequence. And remember, writing the numeric sequence, our first term is minus 2. And then if it is an arithmetic sequence, how do you get the next term when you know the common difference? Like I said, the common difference and first term are very important. What you do is, you take the preceding term, you add it to the common difference, you get the succeeding term. Or, in simple language, you take the previous term, you add it to the common difference, you get the next term. Okay, so in this case, it means if you have minus 2, you'll just say minus 2 plus 5 is 3. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18, so on and so on. But there is something that you start to realize here. Okay, after this term, T1, which is minus 2, all these other terms that you are having here, they end with either a 3, you see? So you are actually having minus 2, 0, 3, 0, 8, 1, 3, 1, 8. If you continue, it will be 2, 3, just like that. You understand? So they will either end with a 3 or with an 8. You see? You have an 8 here. You have an 8 here. If the previous term ended with a 3, the next term will end with a 8. A 3, a 8. That is why it will be from 18, it will be 23. You understand? Then from there, from 23, then it goes on just like that. Okay? So it is either it will be an 8 or it will be a 3. Okay? So now let's check. What does this tell us? If you check all the perfect squares, 1, 4, 9, 16, 25, 36, so on and so on, none of the perfect squares will actually end with an 8. There is no perfect square that will actually end with an 8. As a result, because these terms either end with a 3 or an 8, it means you will never have a perfect square. You will never have a perfect square that will end with an 8 or a 3. Thus, it means none of the numbers in this arithmetic sequence that has a common difference of 5 and first term of minus 2 are perfect squares. Okay? That was very simple. Because no perfect square will ever end with a 3 or an 8. And then in our sequence, our terms are either ending with a 3 or an 8. Then it means, there is no correlation here. As a result, it means none of the terms in this sequence will be a perfect square. Okay? So that's how you get your marks. You'll actually get a mark for realizing, okay, or for discovering that every other term after minus 2 will either end with an 8 or a 3. And you also get a mark for your knowledge of perfect squares. Okay? So saying there is no perfect square, there is no perfect square that will end with a 3 or an 8, then you get a mark for that. Okay? So this is your 2 marks. You see, for your reasoning and for your observation. And then 2 plus 1 is 4 plus the previous 3 for 1.1 is 7 marks. 7 marks is a lot of marks, ladies and gentlemen. I hope you understand. Okay. So this will mark the end of this video. In the next video, I'll be dealing with a question, an example for a geometric sequence. Okay. Goodbye for now, and meet you in the next lesson. And please, like I've already indicated, people, let's subscribe, let's share these videos, and blah blah blah, so on and so on. Let's this year let's reach 1,000 subscribers, 1K subscribers, and celebrate, in South Africa. These videos are very important. Okay, the intention is just to educate the nation, nothing else. Okay, goodbye for now. That is your 7 marks. Okay, my goodbye goes with that 7 marks. Thank you very much. Thank you very much. Please subscribe, like and share with family members, with friends, with whoever that may benefit from this particular video. The baseline is we want to educate the nation, and mathematically, of course. Okay. Now don't forget to hit that notification button so that you'll be notified of my future videos. I will actually leave the links of other videos that I've already uploaded so that you can actually check all the videos. Your comments are very important to me because they help me improve in my next videos. Thank you for watching, and God bless.